All right, where is the practice quiz? Right here. Practice test, rather. Okay, let's just do it all. Then it's on video. You need to watch it again. Get it right. And you can see it again. Okay, so number one, okay, that's just like the first problem on the quiz. It's a Venn diagram with two sets, A and B. Always fill in the middle section first. So does it tell you how many are in the intersection? Oh, no, see, this is going the opposite way. Oh, it's a little bit harder. Maybe that's why you guys have trouble. Now, since I don't tell you how many elements are in the intersection, then you put X over there. Hey, you guys better follow this, because this is what the test is going to look like. Now it says the number of elements in A is 12. So everything in here has to add up to 12. So if that's X, what do I label this?
12 plus X.
No, 12 minus X. Because this plus this got to add up to 12. And negative X plus X cancels out, and that's how you get 12, right? The number of elements in B is 15. So everything in here has to add up to 15. So if this is X, what do I label this? 15 minus X. Then it says the number of elements in A union B is 20. That means everything in both of these sets adds up to 20. So this plus this plus this has to add up to 20. So write that down. This plus this plus this equals 20. And then now you can solve for X. So what would I do? I would cancel out negative X and positive X. So you get 27 minus X equals 20. X equals, subtract 20? 7. And there you go, that's your answer. Because they want to know how many elements are in the intersection. In other words, how many elements are there? The answer is 7. So yeah, it's the same problem, but a little bit different because you got to label it out next. So this problem's going to be on the test, right? Because I just copied it and I changed the numbers. All that you're going to have is the numbers are changed. So make sure you can do that now. This is the last, isn't this the last test of the quarter?
Yeah.
This might be. It might be the last test of the quarter. Okay, now we got 3 sets. So A, B, C. Always fill in that middle section first. Now, in this one, they tell you the number of elements in A intersect B intersect C is 3. That means where all 3 of them overlap. That would be right there. And then just work your way out. Go backwards. The number of elements in B intersect C is 6. Now, where do B and C overlap? Right here, right? Right? That's where they overlap. They have to add up to 6. So if that's 3, what's that? Yeah, that's got to be 3, because they have to add up to 6. The number of elements in A intersect C is 7. So where do A and C overlap? Right here. Everything in there got to add up to 7. So if this is 3, what is that? 4. And you just keep going until you get it all. The number of elements in A intersect B is 8. So where do A and B overlap? Right here. Everything there got to add up to 8. So if that's 3, that's got to be 5, right? Because 5 plus 3 is 8. The number of elements in C is 11. Everything in here got to add up to 11. Well, so far I got 4 plus 3 plus 3, that's 10. So I need one more to make 11, right? The number of elements in B is 15. Everything in here got to add up to 15. So far I got 5 plus 3 plus 3, that's 11. So to make 15, I need 4 more. And then finally, the number of elements in A is 18. Everything in here got to add up to 18. So what do I have so far? 4 plus 3 plus 5, that's 12. How many more to make 18? 6. So the question now is, compute the number of elements in A union B union C. That means in everything that is inside A, B, or C.
You just add it all up.
Yeah, so just add up all those numbers right there. So what would that be? 6 plus 5 plus 4, that's 15, plus 10 is 25, plus 1, 26. You got to fill in the numbers correctly though. Okay, number 3, this is just like the quiz. A code is made up of a consonant followed by a vowel, followed by an odd digit, followed by an even digit. So all you gotta ask yourself is, how many choices do I have, and then multiply those numbers. How easy can it be? Unless you don't know how many consonants there are. But we learned our lesson, right? What if I give Greek letters? What? You guys can't even handle American letters. Okay, so a vowel. How many choices do I have if this is a vowel? 5, and then this is a consonant, 21, followed by an odd digit. Now remember, if you have a hard time, write out the digits like this. These are the digits. How many digits are there? There are 10. Half of them are odd and half of them are even. So this
Wait,
is
it
an
says-
odd digit.
It says consonant, well, it doesn't even matter though. Cause it says consonant, then a vowel.
Really?
Yeah.
Oh yeah, okay, my fault.
What, right?
21, no. 5. How come only Nagami is paying attention? The rest of you are just checked out already, checked out for the day. How good?
Are we gonna play tennis for bonus points again?
Why are you worried about this?
Just pause my mind.
Anyway, the answer is probably no, because look, what did you guys, I had to like,
Oh, you're hurt, that's why.
I'm not hurting, I mean, I'm hurt, but there's no way you can, there's not doing anything now. Well, if I remember, period 7 had 0.
We're not pretty set.
I mean, period 1 had 0.
Oh, we had column one.
Oh, you had 1.
Q.
Yeah, me too.
It was like Q and
Whatever, there's still, you just take the 1%, that's all you can have. Anyway, here's an odd digit. How many choices do you have for an odd digit? Count how many of these are odd?
5.
Okay, even digit,
5.
5. Now here's a question that came up. What about 0? Is 0 an even digit?
No.
Yes, 0 is even. Oh my goodness.
0 is.
Okay, here are the even numbers. 8, 6, 4. You see a pattern? 2, 0, -2, -4. These are the even numbers. Yes, 0 is even. Anyway, if you don't know that, then that's like a -3 then, right? Tomorrow. Okay, -4 then. 4. So we have Al, Ben, Cal, Dan, and Ed. And we're going to arrange them in a row. How many arrangements are possible? That's easy. How many ways can you put 5 people into 5 seats? 5 factorial, right? Or do I have to do this? Here's the 5 seats. I got 5 choices. 4, 3, 2, and 1. That's the same thing. I don't care which one you write. Write down the formula and then write down. So like I said, I don't know how many problems there are, so I think it's going to be 3 points a problem. 2 points for the formula, 1 point for the computation. So can we get 120 from that? Okay, now B, this is the problems I showed you before, but I'm sure you forgot. How many arrangements are possible if Ed must sit in one of the N seats? So remember what I told you to do? You do a specific case. What's a specific case?
And
Like, what if Ed is in seat number 1? See, Ed got to sit either here or there, right? One of the N seats. So if Ed has to sit there, how many choices do you have? 1, because that has to be Ed. Now, any of the 4 other people can sit here, so what? How many choices do I have? 4, 3, 2, 1. But is that the only way Ed can sit in one of the N seats? No, he could have sat in that one as well, right? So how many cases were there? 2, so you gotta multiply your answer by 2. So again, the strategy for these harder problems is you do a specific case and then multiply by the number of cases. And then can I trust you to multiply out those numbers?
120.
44.
12
40.
times 4. 48. So we're gonna lose a lot of 1 point then. 1 point case. C. How many arrangements are possible if Ben and Cal must sit next to each other? We did this problem. Okay, so do a specific case. What if Ben and Cal are sitting in the first 2 seats? This is Ben and Cal right there. So how many choices? Either Ben or Cal?
1.
No, you have 2 choices, Ben or Cal. Now, one person sits down what?
1.
Okay, now there are 3 other people, so how many choices? 3, 2, 1. See, that's the easy part. But is that the only case where Ben and Cal can sit together in seats 1 and 2?
No.
No, they could have said in seats 2 and 3, 3 and 4, or 4 and 5. How many cases was that? 1, 2, 3, 4. So you gotta times it by 4. You know what? I'm gonna leave the multiplying to you. Because right there, you just write that down. That's 2 out of 3 points. Now, if you get this thing wrong, though, that's minus 3 already. You lost everything. What?
So it doesn't
Wait, what
matter
did
the
you say?
order of Ben and Cal,
Hmm?
the cases, when you have to like add up the cases, it doesn't matter if Ben and Cal are like.
Yeah, no, that's why you have 2 choices and then 1. So you don't have to worry about this. This is Ben and Cal. You have 2 choices, either Ben or Cal, and then whoever sat down, then you only have 1 choice left, right? Okay, D. How many arrangements are possible that Al and Ed cannot sit next to one another? You guys don't remember doing this? Okay, let's do a specific case. What if Al and Ed are in each 1 and 3? They have to be separated by at least 1 seat. So, this is either Al or Ed. How many choices? Once this person sits down, how many choices do I have for Al? Okay, now what about those 3 other people? 3, 2, 1. See, that part's easy. But is that the only case where Al and Ed can be separated? No, so you gotta count. How many ways can they be separated? They could be in seats 1 and 3, 1 and 4, 1 and 5. 2 and 4, 2 and 5, or 3 and 5, right? How many was that? 1, 2, 3, 4, 5, 6. There are 6 cases, so you gotta times by 6. So you do a specific case, and then you multiply by the number of cases. Okay, that takes care of number 4. Number 5. We did this one too. How many 3-digit whole numbers are there? Okay, here's a 3-digit number. It's a permutation, so we can use the slot method here. If I have a 3-digit number, how many choices do I have for the first digit? 9. Anything except the 0. Remember, 0 cannot be the first digit. How many choices do I have for the second digit? No, because it doesn't say you cannot repeat. It just says how many 3-digit numbers are there. So that means you can repeat. So you have 10 choices and then 10. So there's 900. Or you could just go like this. I showed you this before. What's the smallest 3-digit number there is? What? 20.
I didn't say 20.
What's the biggest 3-digit number?
999.
999. How many numbers are there from 100 to 999? You subtract and then add 1, right? Remember that? So if you subtract that minus that, you get 899 plus 1. 900, see, either way. 900. It's easier to do the multiplication principle.
Why is it 10? First, second, third.
Because it doesn't say you cannot repeat digits.
Wouldn't it be?
So if you cannot, if it doesn't say you cannot repeat, that means you can repeat. So you have 10 choices.
But why is the first one 9?
Because the first digit cannot be 0. You cannot use 0 for the first digit, so that's why you only have 9 choices. This is like the 3rd time or 4th time we did it, huh? What, you guys, what is this, Monday? You guys cannot think.
It is.
Yeah, that's what I'm saying. How many 3-digit whole numbers contain no 7s at all? Well, how many choices do I have for the first digit if it can't be a 0 and it can't be a 7? You got 8 choices. What about the second digit? It just can't be a 7. So you got 9 choices, and then what about the 3rd digit? 9, very good. And then you multiply those numbers and you get 81 times 8, 648. Now in part C, how many 3-digit whole numbers contain at least 1 7? Remember, I showed you guys this on the board. Nobody remembers anything because it was 1 week ago. This is how many total 3-digit numbers there are. This is how many don't have any 7s in them. So how many would have at least 1 7? What do you do? Yeah, just subtract those numbers. 900 minus 648 is
252.
Thank you. Some of you have a hard time borrowing, huh? You guys understand that? Because either a number has no 7s in it or it has at least 1, right? So if you can find these two, all you have to do is subtract. All right, 6. A committee of 5, so once you read that word committee, hey, this is gonna be a combination now. So if you do a slot method on a combination problem, that's all wrong already, it's -3. You can't get any partial credit. A committee of 5 is to be selected from 5 boys, so there's 5 boys and 6 girls. And we're going to make a 5-person committee. So what do you think on tomorrow, whenever the test is? Probably can make a 6-person committee. Just change the numbers. Okay, what number are we on? 6. How many committees are possible? Well, how many total people are there? There's 11 people, and I want to select 5 people. So how many ways can that be done? 11C5. Now, I don't care if you write it like that, or you write it like this, or you write it like this. They all mean the same thing. I don't care which way you write it. Now, you're not going to get to use a calculator now, so you got to compute now. How do you compute 11 choose 5? 5, 4, 3, 2, 1 on the bottom if we use the shortcut method I taught you. And then what goes on the top? 11, 10, 9, 8, 7. And then you just let the canceling begin. Okay, what I would do is I would go 4 times 2 cancels 8. 5 goes into 10. 2 times. 3 goes into 9. 3 times. So all you have to do is multiply 22 times 21. You guys can do that, right? Well, we'll find out. Won't we? See, you don't have to worry. All the answers will be less than 1 million, like I told you. If any answers comes out to more than 1 million, I just give everybody credit on their problem. Okay, what's the next one? Oh, we're 6AB now. How many committees are possible if each committee must contain 2 boys and 3 girls? Okay, this was on the homework. Now, I want to select 2 boys. How many boys do I have to choose from? 5. So, how many ways can I select the boys? 5, choose 2. I'm going to write it like that. Now, I need to select 3 girls, and how many total girls are there? 6. So how many ways can I select the 3 girls? 6, choose 3. Now, the question is, what do I do with these numbers? Do I add them or multiply them?
Multiply.
How come you multiply?
Because
Because they're occurring together. If things occur together, that's when you multiply. If things cannot occur together, that's when you add. So if they're serving on the committee together, you multiply them. Okay, why don't we just do this? How do you compute 5 choose 2? 5 times 4 over 2 times 1. How do you compute 6 choose 3? 3, 2, 1 on the bottom and 6, 5, 4 on the top. So what kind of canceling can I do? 2 goes into 4 2 times. 3 times 2 cancels 6. So you got 10 times 20. I think you guys can handle that. Who knows? And then C. There's no C. You like the sauce, eh? Using only the face cards from a standard deck of cards. Okay, before we even move on, do you guys know what face cards are?
Yeah.
Those are cards that have a face on it. In other words, we're talking about
Jack.
kings, queens, and jacks. No, no, no! It says standard deck of cards.
There's jokers and
That's not a standard deck. A standard deck is 52 cards. Okay, so how many cards are there that's either a king, a queen, or a jack?
12.
There's only 12 cards, so there's 12. Okay? So it says, using only the face cards, how many 3-card hands are possible? In other words, if I were to deal, like, I have 12 cards in my hand, how many ways can I deal 3 of them? Or like, this is like 12 candy bars, how many ways can I select 3 of them to throw in my lunchbox? 12, choose 3. This is a combination problem, because when you have cards, the order is not important. And how do you compute 12, choose 3? 3, 2, 1 on the bottom, 12, 11, 10 on the top, and 6 goes into 12 2 times, and everybody can go 22 times 10, right? I would think. Multiplying by 10 is baby food. Maybe some of you forgot your bib. 8A. How many 8-letter words can you make using these letters? A, B, C, D, E, F, G, H. Now remember, a word is not a real word, but just an arrangement of letters, yeah? So, how many ways can you arrange 8 things in a row, basically? That's what it is. Isn't the answer just 8 factorial? Okay, then good luck computing that, right? Anyway, look, you write that down, that's 2 out of 3 points, right? That's pretty good.
multiply it correctly?
Only if you want the third point. And then 8B, how many 8-letter words can you make from these letters? A, B, and C. And again, you have 8 letters, but this is just like alfalfa or Mississippi or beekeeper or whatever, yeah? So if these were all 8 different letters, the answer is 8 factorial, but there's 3 A's. So how do I adjust? What do I do? You divide by 3 factorial. Got 3 B's. Got 2 C's. And there you go. And then you compute it. Okay, we did this last week. Let's hope you guys remember something. Okay, so here's the city block. Okay, let me draw it correctly. 1, 2, 3, 4. I want to get from A to B like that. How many different, if you can only go east or south, in other words, you can't go backwards, how many different paths are there? You guys remember?
Well, you go 5 factorial.
Well, no. So look, no matter what, to get from A to B, don't you have to go 5 times east? Look, 1, 2, 3, 4, 5, right? So no matter what, you have to go 5 times east. No matter what, how many times south do you have to go? 3, right? So S. So now, how many 8-letter words can you make? So that's just like this problem right here. How many 8-letter words can you make with 5 E's and 2 and 3 S's? Because every time you make a new word, that's like a different path that you take. So again, if these were all different letters, the answer would be 8 factorial, right? But then, you got 5 E's. How do I adjust for that? And then you got 3 S's. And then you guys can compute that, right? In fact, you do it in your head. 56, right? Maybe you can't do it. Do you guys understand why it's 56? Okay, so number 10, just nod your head. Yeah? 2 4-sided dice with the numbers 1 through 4 are rolled. Okay, already you know. How did we do dice problems? When we did the probability section? Write out all the possibilities. Now, what can happen when you roll 2 dice, but they're 4-sided dice now? They're not 6-sided dice. So what do? What can happen when you roll 2 dice?
What?
You can get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4. 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4. 3 and a 1, 3 and a 2, 3 and a 3, 3 and a 4. 4 and a 1, 4 and a 2, 4 and a 4 and a 3, 4 and a 4. There you go. There's 16. So you know the answer could be something out of 16 already. So what does it say? What's the probability that the sum of the 2 numbers is a 6? Okay, so where do the 2 numbers add up to 6? Right there. Remember how they come in diagonals? Or you guys forgot that too?
The triangle.
So, how many is that? How many do they circle? So the answer is 3 out of 16. That's the probability of rolling a 6. Okay, part B. What's the probability that the sum of the 2 numbers is a prime number? Okay, now you guys remember what the prime numbers are? Let's just circle them in blue. Is 2 a prime number? 1 plus 1.
Yes.
Is 3 a prime number? Yeah, 3 plus 3. 4 is not a prime number. 5 is a prime number. 6 is not. What about 7?
Yeah.
Yeah. What about 8? No. So how many numbers did I circle? 1, 2, 3, 7, 9. So the answer is 9 out of 16. So again, if you can write out the sample space, remember the sample space is just a listing of all the possible outcomes, then it's easy to do probability. You just count.
Oh, so it's the prime number of sum.
Are you reading? Compute the probability that the sum of the 2 numbers is. Now, do you notice that I said the sum of the 2 numbers facing down? Did anybody wonder about that? No, because I'm reading it for the first time now, Mr. Park. Why did I say facing down? Oh boy. Okay, think about it. What does a four-sided die look like? No, that's a six-sided die. What's a four-sided die look like?
Pyramid.
It's a pyramid, that's right. It's a pyramid. It has four sides, it's a pyramid. So if you roll a pyramidal die like this, three of them are facing up and only one of them is facing down, so that's why I said down.
It doesn't affect the problem.
Yeah, it doesn't affect the problem, but I was just wondering if you guys even notice anything. Never mind. I'm depressed me already. Number 11. The spinner shown is spun. So you have a spinner like this. 1, 2, 3, 4, and you're gonna spin the thing like that. Okay? And then you're gonna roll a die. I'm gonna draw a picture of a die. So you're gonna spin this, and then you're gonna roll a die. What is the probability that the spin is a 3 and the die shows a 5? Well, what's the probability of spinning a 3 here? 1 out of 4, right? Okay. What's the probability of tossing out? I forget the number already. A 5. What's the probability of rolling a 5?
6.
1/6. Okay, now, what do I do with these two numbers? Do I multiply them or do I add them?
Multiply to add.
Yeah, very good. See, some people remember. And, if you see the word and, that means multiply. If you see the word or, that means add. So what's the probability of this and that happening? That's why you multiply. And I'm assuming we know how to multiply fractions, right? Hey, we almost finished already. So even though this test looks kind of long, it's really not that long. You know? Probably the hardest part for you guys is just multiplying the numbers. Okay, number 12. 2 people are randomly selected from Al, Ben, Cal, Dan, and Ed. Compute the probability that Cal is selected on this committee. Yeah. Okay, so I have 5 people. How many ways can I select 2 of them? Well, the answer would be 5 choose 2, right? But you have to write them all out. Anyway, what is 5 choose 2? 5 times 4 over 2 times 1. 10. Okay, so if I write them all out, there should be 10. So see, that's kind of like you can double check that, right? So what can happen? How many ways can I select 2 of these people? A and B, A and C, A and D, A and E. See, I did all the ones with A, now do the ones with B. B and C, B and D, B and E. C and D, C and E. D and E. Hey, good thing, Mr. Park. That's bowling right there. Okay, now answer the, so we know the answer is going to be something out of 10. What's the probability that Cal is selected? Well, out of all of these, just circle the ones that Cal is on. Like, where do I see Cal? Right there's Cal, 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 Cal. That's it. So what? 4 out of 10. And you can reduce that to 2/5, right? Easy. Now, you want me to show you another way to do it? No. Okay, because some of you could actually do this without writing it out. You can just use, okay, here. I'm just going to show you. If you want to pick it up, you can. Otherwise, you write it out. Okay, so everybody understand why the denominator is 5 choose 2, right? Because out of these 5 people, how many ways can you select 2 of them? 5 choose 2. Okay, but what about the numerator? How many ways can Cal be on the committee? Now think about it. If Cal is already on the committee, we don't even have to count them already, right? So out of the remaining 4 people, how many ways can I select 1 of them? 4 choose 1. Because Cal is already on the committee, so that means you only need 1 more person. You get it? So out of the remaining 4 people, how many ways can you select 1 of them? 4 choose 1. And then that's the answer, which is 4 over 10, which is the same thing. All right. So if you noticed on this, there's no poker hand, so you don't have to worry about poker. Okay, and finally, the last 3 problems deal with the binomial theorem. Do we still remember that, or is that gone from the memory? No, we do have cards right over here. 2 cards are drawn from a standard deck of cards. Okay? what's the probability that both of them are spades? Okay, we did a problem like this before. Okay, so here's the deck of cards. What's the probability that I reach into the deck and pull out a spade? 13 out of 52, correct? Everybody knows there's 13 spades, 13 clubs, 13 hearts, and 13 diamonds. That's why 13 times 4 is 52 cards. Okay? Now, what's the probability that I reach in and pull out another spade?
12.
Look, I already took out one of the spades from the deck, so there's only 51 cards left in the deck, and there's one fewer spade. So what's the probability of pulling out another spade? 12 out of 51. Spade on the first and then spade on the second. Okay, now, how come I multiply them? Yeah, because, well, yeah, together plus it says and, right? What's the probability of getting a spade on the first and a spade on the second, right? Okay, and then you gotta simplify this. But like I told you, cards simplifies nicely. 13 goes into 52. 4 times. 4 goes into 12. 3 times. 3 goes into 51. Okay, 17 times. So the answer is just 117. Nice and easy. Now, what would happen if on the test? What if it said 3 spades? I'm going to pull out 3 cards. What's the probability of 3 spades? Well, it'll be 12 out of 52 times, and then what's on the spade? What am I saying? 12, 13, 12 out of 51, and then 11 out of 50. Now, can you see now the computations are going to get tough? Because look, that goes into that 4, 4 goes into that 3, 3 goes into that 17. Yeah, that's not that bad. 11 over, you guys know what 17 times 5 is, right?
Yeah.
What?
850.
See? Easy. And then you can do 4, 5, 6, whatever. Yeah. Okay, now the last 2 problems deal with the binomial theorem. Expand x plus y to the 6. So if I were to expand x plus y to the 6th power, how many terms would there be?
7.
There would be 7 terms. You have to write them all out. So what do you want to do? You want to write out Pascal's triangle? Or do you want to do the 6 choose 0, 6 choose 1 thing?
The easiest one.
Well, to me, I think it's easy to do the choose thing. So remember how it starts with 6 choose 0? X to the 6, and 6 choose 1. Then remember, the powers of x are going down by 1, and the power of y's go up by 1. So x to the 5th y. And then 6 choose 2, x to the 4th y squared. Remember, the 2 powers always got to add up to this now. The next one going to be 6 choose 3, x cubed y cubed, right? 6 choose 4, x to the powers of x are going down by 1, 2 y to the 4th, plus 6 choose 5, x to the 1st, y to the 5th, because the 2 powers got to add up to 6. And finally, 6 choose 6, x to the 0, y to the 6. But we're not going to write x to the 0 because that's 1, yeah? And then what you need to do is you need to compute each one of these. Obviously, this is going to be worth more than 3 points. Because it's not going to be like that. In fact, whatever. Okay, let's compute. Remember, anything choose 0 is 1, so x to the 6. Anything choose 1 is anything. Okay, now we got to compute 6 choose 2. But that's easy. That's just 6 times 5 over 2 times 1. 2 goes into 6 3 times? 15. Now it's up to you. If you'd rather make Pascal's triangle, you're going to get the same numbers anyway. 6 choose 3. That's 6 times 5 times 4, all over 3 times 2 times 1. The 6's cancel, so what are you left with?
20.
20. So you get 20 x cubed y cubed. And then, once you reach the halfway mark, you don't even have to, because look, 6 choose 4 is the same as 6 choose 2, right? So what? Because you know, Pascal's triangle, it's symmetric about the center line, right? So you don't have to compute anymore. So it's going to be 15x squared y to the 4th plus 6x y to the 5th plus 1 y to the 6th. See how the numbers are symmetric? No, I don't, like I said, I don't know what's easier for you. Make Pascal's triangle? That's not not that hard to make Pascal triangle. 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. That's the one we want. See? So I don't care which way you do it, just make sure you do it correctly.
Actually, the Pascal triangle is pretty good.
Yeah, but then what if on the test it's 7th power?
Just go home right
Yeah, it's not hard. How hard can this be? This is algebra 2B, right? And then finally, the last problem, find the 8th term of x plus y to the 10th. See how I make my problems a little bit easier than the book? Because remember the book had like x squared minus 2y or something. Let's keep it simple like this. So if I were to expand this, there would be 11 terms, right? We're just finding the 8th term. Okay, so what? Every term is going to be 10 choose something, right? Just like over here, when you raise it to the 6th power, it's all 6 choose something, right? So if it's x plus y to the 10th, it's going to be 10 choose something. So if I want the 8th term, what number do I put there? 7, right? One less. Look, here's the first term. Remember, I showed you this. Here's the second term. Here's the third term. Here's the fourth term. This number is always one less than the term that you want. So if you want to find the 8th term, that number is a 7 over there. And then what's the pattern? We forgot the pattern. Ah! Look, whatever number's on the bottom, hey, that's the same thing as the power of y. Look, if that's a 3, that's a 3. That's a 4, that's a 4. That's a 5, that's a 5. So once you put the 7 down there, that means the power of y got to be 7. And then you know the two powers got to add up to 10. So what does this power have to be here?
now.
3. And then now all you have to do is compute 10 choose 7. But 10 choose 7 is the same thing as 10 choose 3. So using the shortcut I taught you, 3, 2, 1 on the bottom, and then 10, 9, 8 on the top. So 3 goes into that 3, 2 goes into a 4, so 12 times 10, 120. So your answer is 120 x cubed y to the 7. Or if you want to, if you don't like what I'm teaching you, then just expand the whole thing, 11 terms, and then box the 8th one. I guarantee it could be this one. See, after going over it, this isn't that bad. All right. So we finished early once again. So you have are you serious? 27 minutes remaining. And look, usually what we do is go on to the next section, but we're not going to do that. We are. Oh yeah, that's right. I thought we ended at 15. So we have 12 minutes. Anyway, usually we go on to the next section, but we're not. So there's no homework tonight. In fact, there's no more homework already. That's it. Until after vacation. Just look, study for tests. You don't test tomorrow. The test is child's play.
Oh, you don't even see you like twice.
Wait, why is Michael gone? I saw him in class upstairs.
No, he said he was sick. He's going home.
Liar.
Like you never lied before. Yeah.
But he's always sick, Mr. Bart.
Well, some people just have a propensity to get sick.
Hard, do you happen to have any more of the practice tests, blank ones?